All right, are y'all ready? This is going to be 3.2, part 2. And we're still discussing this idea of domain and range of functions. Domain and range, okay? And the topic of discussion today is piecewise functions. Piecewise, and so I was hearing, can you spell that? Yes. A piecewise function. Piecewise. Well, good for you. I bet you did. A piecewise function is a function in which more than one formula is used to define, okay, so more than one formula is used to define the output over different pieces of the domain. A piecewise function is a function in which more than one formula is used to define the output over different pieces of the domain. Piecewise, okay? So what we're looking at here are pieces of functions. Pieces, parts, okay? And I'm trying to find exactly what I'm looking for. Here we are. Okay, so it says on the top of page 190, which you guys can't see, here's what a piecewise function looks like, okay? It's going to look like f of x, and it's going to have equals. And then you're going to see this brace or bracket situation. And then you're going to have multiple equations. So for instance, you'll have the first formula, maybe called it formula 1. And we're going to use that formula if x is in domain 1. We're going to use that particular formula if the x value that we're looking for fits into the domain that they give. Okay? And then we're going to have a second formula. We'll call it formula 2. And we're going to use that one if our x value is in domain 2. And then, there's no limit to how many formulas you could have. So we'll call it 3 this time. Formula 3, if our x value is in domain 3. Okay. This is going to make a whole lot more sense when we start doing it. All right. So here comes example. Everybody got this written down? Okay. So here is example 11. Example 11. I'm going to read it to you. It says, a museum charges $5 per person for a guided tour with a group of 1 to 9 people. $5 per person if the group has 1 to 9 people in it. Okay? Or a fixed $50 fee for a group. How much does it cost to get in? Well, what does it depend on? The size of your group, right? So we're going to write a cost function here. Cost as a function of the number of people in the group. And you got 2 different scenarios. It's either going to cost $5 a person if what? So we call that 5N. $5 per number of person. Number of people. 5N. If How many people?
1 to 9.
Okay, 1 to 9, or how about 0 to 10? Not or equal to 10, just less than 10. That would be 9. So we're saying if n, the number of people, fits between 0 and 10, not including 10. And honestly, not including 0 either, because if I included 0, who cares? Nobody's going to the museum, right? So on the interval from 0 to 10, this is the function that we use. Y'all with me? It said also $50 fixed fee for a group of 10 or more. So how much does it cost? $50. Not depending on how many people there are. Because if there are more than 10 people, we're going to this function, $50 max. If, what?
Greater than 10. If it's greater than 10.
Or equal to 10. Because at 10 and up, we charge $50 for the group. Okay? So this is an example of a piecewise function. You can see why it would be necessary to have two different functions here. If my friends and I roll up and we've got only 7 people, it's cheaper for us to pay $5 a pop, right? I don't want to walk up and say, oh, there's a group and I can't count, so charge us $50. That doesn't help. I want to be able to say, hey, with only 7 of us, it should cost us $35. But what's really cool is if I take a group of 11 or a group of 30, it seems to not matter. It seems like it's going to take us $50, period. Cool? Can you read it? Do you understand it? Okay. All right, let's go on. This is going to be example 12, and it says working with a piecewise function. So we've got a cell phone company. Oh, cell phones. They're the topic of the day. A cell phone company uses the function below to determine the cost in dollars for gigabytes of data transferred. Don't we all have Okay, so we've got the cost per gigabyte. And it costs 25 if the number of gigabytes used is between 0 and 2. $25. And it's going to cost $25 plus 10 per every gigabyte over 2. If, what? What's my domain here? If G is greater than 2. Did you know back in the olden days when we actually talked on the cell phone, right? When we called people and we had conversations voice to voice. We called them and we were charged per minute of conversation. Did you know that? Yeah, you cost dollars or cents per minute. I think it's like 10 cents a minute. 10 cents a minute during the daytime. But then at night, they wouldn't charge you to talk during the nighttime. So if you waited till 7 o'clock, then you could have unlimited conversations. See, this is very nice. These cell phone companies, they did the things. Now we just text and we don't worry about it. Here's the question. Find the cost of using a 1.5 gigabyte. So what does it cost to use 1.5 gigabytes? And what does it cost to use 4 gigabytes? So how do I find C of 1.5? Plug it in. Plug it into which function? 1.5. Where does it fit? It's under 2. So it still costs $25. So because it's a piecewise function, I have to look at my input, which is this 1.5, and I have to find which domain that number fits in. Does it fit in the top one, 0 to 2, or is it greater than 2? And that tells me which function I can use. You following? It's a piecewise function. I might have to use different pieces of this function depending on my domain. How much does it cost to use 4 gigs? Okay, because 4 is greater than 2, Now I'm using function 2. Yeah, so we're just going to use this function. And we're going to plug in our 4 in place of g. So it's going to cost that base of $25 plus $10 times 4 minus 2. 10 times how much?
20.
Plus 10 times 2, which is 20. So 25 and 20 is?
45.
Cost me $45 to use 4 gigs of data. I kind of get iffy on this part right here where it says g minus 2. The reason they take off the 2, g minus 2. Why do you think it says minus 2? Yeah, you're already paying $25 for the first 2. I don't want to be charged an additional $10 per gigabyte for those 2 as well. The first 2 are already handled in the top function where I'm paying $25 flat up to 2 gigabytes.
Hello.
Hello. Y'all understand? Yeah, what?
Can I go to the restroom?
Yes. Okay, so here we go to example 13. Take his pass.
What?
Just take it. I don't know. Example 13. It says sketch the graph. Sketch the graph. It wants us to draw a pretty picture. And our function for example 13 says f of x equals, and we've got 3 functions here. F of x equals x squared if x is less than or equal to 1. Yeah? F of x equals 3 if 1 is less than x is less than or equal to 2. So in other words, if x is between 1 and 2, my function looks like 3. And lastly, f of x equals x if x is greater than 2. Cool beans? Okay. All right, so I'm going to try to fit it all on a pretty graph right in this area. And I'll color code mine so you can see what we're talking about. The first one's going to be x squared if x is less than or equal to 1. Okay, so I have to kind of envision x squared. What kind of shape is it?
Problem.
It's a parabola, right? It's supposed to be quadratic, supposed to show the whole picture of this parabola. If I didn't have these domain restrictions, let's sketch that out. Let's see what it might look like. I would have a point at 0, 0. If I input x equals 1, what is 1 squared? 1. So I should have a point at 1, 1. Right? If I input a point at 2, what do I output? 2 squared. 4. 1, 2, 3, 4. So way up here somewhere. Okay, and I'm very lightly drawing that. Let's go back to the left a little bit. If I input -1, what's the output?
1.
Also 1. It bounced. When I square -1, negative times a negative is a... Okay. Let's go to -2. +4. 1, 2, 3, 4. For the same reason that it was +1. Okay. So I've got these dots here, but I only want this function if x is less than 1. So I'm actually not interested in any of this function beyond x equals 1. I only want this function on the interval from -infinity to +1. And I stop. What kind of circle does it have here? Is it closed in or is it open?
Close.
It's closed in because x is allowed to equal 1. Everybody got a good picture here? Yeah? Okay. So next, we're going to graph the second piece, which says x is 3. F of x is 3 if x is between 1 and 2. So f of x equals 3. There's 1, 2, 3, 4, f of x equals 3. That's what kind of line? It's a constant. Who remembers from your toolkit function what constant lines look like? Horizontal. Flat line. Horizontal. Located at the value f of x equals 3. So I'm going to go up 3, and then I'm going to draw a horizontal line on the interval only from 1 to 2. Also, note that x is not equal to 1 here. Note that it's just greater than. Can you see that? So at 1, it's going to have an open circle at 3. Open circle. And then I'm going to draw a line straight across. And then at 2, what kind? Closed. Right here. Color it in. Good so far? Next. Last one. What color? Duncan, what color?
Red.
Red. Y equals x. What kind of line is that? Or what kind of function is that? Y equals x. Identity. It's linear. Linear. It's going to start at the origin, right? And if I pretend to kind of map it out, I know that it's going to go rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. But note that I'm not actually putting things on my paper yet. Because I'm only interested in this line from where? Greater than 2. Or equal to 2? No. So at 2, it's going to be an open circle. And I'm only interested in what this line looks like moving to the right after 2. I don't care anything about how this line behaves at the origin or how it behaves at 1. I am only interested in this piece from 2 on. Yeah? Do we understand? Okay. So if I asked you to use this piecewise function to find f of -1, what would you do? You'd go to the green one, because where is -1? Less than 1. So you'd go to the green one, and you would input into that function, -1, and you would output what? +1. Okay. If I asked you, what is f of 4? You'd go to the red one. Why would you go to the red one? Because 4 is greater than 2. Yep. Okay. All right. Is f a function? Is f a function? For every input, is there only one output?
Yes.
So where are your problems, Ailey? She's saying not for all of them.
Because for the red one, isn't there only one output?
It feels like on the red one, there's a dot at 2. If I input 2, there's a dot right here at +2 and a dot right here at +3. Right? That doesn't pass the vertical line test. Except at 2, one is open. The bottom one is open, which means the value doesn't exist here. So in fact, there's only one value at 2. Because this one is closed and this one is open, only one of them counts for being the value at x equals 2. So it actually is a function. It does pass the vertical line test. But if this was a closed circle on the red at 2, it wouldn't be a function because you would have 2 outputs for that one input. Cool? Okay, let's go on. Are y'all sleepies?
Yes.
We have one problem left. We have a try it that goes with this particular example, and we're done. Can you lick your eyelids and get them going again? Y'all need to stand up and sing?
No.
I can pause it. Watch.
No.
All right, now that we have done our exercises and our stretchings, this is our last problem here. It says graph. This is the try it that goes with the last example. Graph f of x equals, and we've got our 3 problems here, x cubed, if x is less than -1, f of x equals -2 if Negative 1 is less than x is less than 4. So somebody put that into real words for me. Yeah, this is the try it. Good, if x is between negative 1 and 4. So what kind of number might fall between negative 1 and 4? 0, 1, 3. Got a lot of them, right? Okay. And then lastly, f of x equals the square root of x. If x is greater than 4. F of x equals square root x if x is greater than 4. Okay. Judson, what color? Yellow? He said yellow, y'all. The yellow's not going to show up. Pick a better color. Huh? Blue. Blue, he says. Blue. Okay, so on our picture, on our graph, easy. On our picture, we're at x cubed if x is less than negative 1. So should I maybe start at 0 and then go left? That's what I think. I don't think I'm interested in x cubed, which I know is going to look something like this on this side. But I don't really care at all what's happening to the left of 0. Okay, so starting at 0 and working my way back to the left, if I put in 0 here, 0 cubed is 0. Okay, still don't want that value though. What if I put in negative 1? Negative 1 cubed. Also negative 1. Okay, so there's my first value. Is it a closed-in circle or an open circle? Is it?
Oh wait, it's open because it's not.
Ooh, it's not or equal to. Not or equal to. Just an open circle at negative 1. Negative 1 comma negative 1. And that's actually our starting place. So I didn't want the origin value at all. Put in negative 2. Negative 2 cubed. Negative 8. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. That's going to be way down here somewhere. And what's going to keep happening as I go to the left? It's going to keep going. That domain goes to negative infinity. So it feels like this is kind of that function. It's just going to get wider and wider and wider. Can I go up a little bit? That's okay. Is that better? Is that better? Okay. What color next? Pink. Pink. Pink for y equals negative 2. Y equals negative 2 if x is between negative 1 and 4. Where's that? That's going to be down on my y-axis at negative 2. Right? Negative 2. Y equals negative 2. What kind of function is that? Constant. It's a horizontal line that goes from where to where? And open or closed on both ends? Open on both ends. So 1, 2, 3, 4. This one's going to go all the way across at y equals negative 2. And it's open on both ends. So from negative 1 to 4.
Negative 1 to 4 on.
At negative 2. Horizontal line going through y equals negative 2, starting at x equals negative 1, and going all the way to 4. Good? Now, we're going to use y equals square root of x. What color, Britton? Red. Going to use y equals square root x if x is greater than 4. Okay? So we need to kind of map out in our minds, what does that square root of x look like? That function. It's kind of that archy thing, right? I'm seeing Maisie draw something that looks like this. She's not wrong. Okay? But we're only interested in that function starting at x equals 4. So we need to get some values here. Square root of 0 is 0. Okay, so that one would be at the origin. Square root of 1 is 1. Square root of 1, 1. Right? Square root of 2? I don't know. Square root of 3? something. Square root of 4, 2. That's an absolute number that we know. Exact value, square root of 4 is 2. So at 4, we're going to go up to 2. And then we start our arc. All right? And it's just really a continuation of this one that we already began. What kind of circle do I have at 4, 2? Open circle. And from that value, we continue this function up and to the right. And we actually shouldn't show any of this leading up to that number. You got an eraser? Sorry. Do you understand, though, why we don't show that part? Because I'm not interested in the function from 0 on. I'm interested in that function from 4 on. Okay? Okay, so listen. What is f of 2? -2. F of 2 is -2. So I have to find in this domain, where does 2 fit? It fits in the pink one. And so I go input -2, output 2. Input +2, output -2. Okay. Are you ready? What is f of 9? 3. Good. So 9 fits in the red one. It's greater than 4. So I plug a 9 into this function. Input 9, output 3. Yeah? Okay. Last one. What is f of -3? Not 8. Not 17. You're getting warmer. 3 times 3 times 3. Negative. Boy, howdy. -27.
I said that.
You did. I didn't hear you. -27. So we'd be at -3, -27. You fit that -3 one into the top. Okay? Guys, this opens you up to do all of your homework.
Wow, man, I hate this so much.
Okay, awesome. This is going to be homework that is due tomorrow. Deal?